What is a cosmic explosion? A cosmic explosion happens when a star has arrived at the finish of its life and detonates in a splendid eruption of light. Cosmic explosions can momentarily eclipse whole systems and transmit more energy than our sun will in its whole lifetime. They're likewise the essential wellspring of weighty components known to mankind. As per NASA, cosmic explosions are the biggest blast that occurs in space. Another cosmic explosion called SN 2023 IXF has been standing out as truly newsworthy since it initially burst into view on May 19, 2023, when cosmic explosion tracker Koichi Itagaki from Yamagata, Japan, detected another splendid spot in the pinwheel world. The cosmic explosion was affirmed the next day by the Zwicky Transient Office in California. Supported connections. Different civilizations recorded cosmic explosions sometime before the telescope was concocted in the 17th century. The most seasoned recorded cosmic explosion is RCW 86, which Chinese cosmologists seen in AD 185. Their records show that this visitor star remained overhead for a very long time, as indicated by NASA. The Crab Cloud, seemingly the most renowned cosmic explosion, was first spotted by Chinese and Korean space experts who kept this star blast in their records in 1054. Local Americans might have considered it to be, well, as per rock artistic creations tracked down in Arizona and New Mexico. The cosmic explosion that shaped the Crab Cloud was brilliant to such an extent that those early cosmologists could see it during the day. Different cosmic explosions that were seen before the telescope was imagined happened in the years 393, 1006, 1181, 1572, concentrated on by popular stargazer Tycho Brahe, and 1604. Brahe expounded on his perceptions of the new star in his book De Nova Stella, which brought about the name Nova. The expression cosmic explosion was first utilized by Walter Baade and Fritz Zwicky at Mount Wilson Observatory, who involved it according to a dangerous occasion they noticed called S Andromedae, otherwise called SN 1885A, situated in the Andromeda world. The researchers recommended that cosmic explosions happen when standard stars break down into neutron stars. Related, when will the sun pass on? At the point when stars pass on. By and large, a cosmic explosion will happen once like clockwork in a universe the size of the Smooth Way, as per research by the European Space Organization. This implies a star detonates like clockwork or so someplace in the universe as per the US branch of energy. Around quite a while back, a bunch of cosmic explosions made the nearby air pocket, a 300 light-drawn-out, nut-formed air pocket of gas in the interstellar medium that encompasses our planetary group. Precisely the way that a star passes on depends to some extent on its mass. Our sun, for instance, needs more mass to detonate as a cosmic explosion. However, the news for Earth actually isn't great in light of the fact that once the sun runs out of its atomic fuel, maybe 2 or 3 billion years, it will enlarge into a red monster that will probably disintegrate our reality before bit by bit cooling into a white midget. Yet with the perfect proportion of mass, a star can wear out in a red-hot blast. Sorts of cosmic explosions. A star can go cosmic explosion in one of two ways. Type 1 cosmic explosion. A star collects matter from a close-by neighbor until an out-of-control atomic response touches off. Type 2 cosmic explosion. A star runs out of atomic fuel and implodes under its own gravity. Type 2 cosmic explosions. We should check out the seriously intriguing sort 2 first. For a star to detonate as a kind 2 cosmic explosion, it should be a few times more monstrous than the Sun, with estimates ranging from 8 to 15 solar masses. Like the Sun, it will eventually run out of hydrogen and then helium fuel at its core. However, it will have sufficient mass and pressure to fuse carbon. Then, gradually heavier elements build up at the center, and the star forms onion-like layers of material, with elements becoming lighter toward the outer layers of the star. When the star's core surpasses a certain mass, known as the Chandrasekhar limit, it begins to collapse. Hence, these Type II supernovae are also known as core collapse supernovae. Eventually, the collapse rebounds off the core, ejecting the stellar material into space, forming the supernova. What's left is a super-dense object called a neutron star, a city-sized object that packs the mass of the Sun into a small space. Type II supernova subcategories are defined based on their light curves, which describe how the intensity of the light changes over time. The luminosity of Type IIL supernovae declines steadily after the explosion, while the luminosity of Type IIP supernovae remains constant for a longer period before declining. Both types have the signature of hydrogen in their spectra. Stars significantly more massive than the Sun, around 20 to 30 solar masses, might not explode as a supernova, astronomers think. Instead, they collapse to form black holes. Type I cosmic explosions. Type I cosmic explosions lack the hydrogen signature in their light spectra and are generally thought to originate from white dwarf stars in a close binary star system. As the gas of the companion star accumulates onto the white dwarf is progressively compressed and eventually triggers an out-of-control nuclear reaction within that ultimately leads to a catastrophic supernova eruption. Astronomers use Type Ia supernovae as standard candles to measure cosmic distances, since all are thought to explode with equal brightness at their peaks. Type Ib and IC supernovae also undergo core collapse in a similar manner, but they have lost most of their outer hydrogen layer. In 2014, scientists identified the faint, hard-to-find companion star to a Type Ib supernova. The search took 20 years, as the companion star shone much dimmer than the bright supernova. Reverse shockwave staggering cosmic explosion symbolism. Supernova remnant G344.7-0. One has been studied using the Chandra X-ray Observatory. Recent studies have found that supernovae vibrate like giant speakers and produce an audible hum before exploding. In 2008, scientists caught a supernova in the act of exploding for the first time. While examining her computer screen, astronomer Alicia Soderberg expected to see the faint glowing smudge of a month-old supernova, but what she and her colleagues saw instead was a strange, incredibly bright, 5-minute burst of X-rays. With that observation, they became the first astronomers to catch a star in the act of exploding. The new supernova was named SN 2008D. Further study has shown that the supernova had several unusual properties. Our observations and modeling indicate this to be a rather peculiar event. To be better understood in terms of an object lying at the boundary between normal supernova and gamma-ray bursts, Paolo Mazzali, an Italian astrophysicist at the Padova Observatory and Max Planck Institute for Astronomy, told Space.com in a 2008 interview. More recently, astronomers have been getting excited about a newly discovered supernova in the Pinwheel Galaxy, designated SN 2023 ISF, and located about 21 million light-years from Earth. The new supernova is attracting the attention of both professional and amateur astronomers worldwide who are turning their telescopes and cameras toward the spot to observe this rather rare phenomenon.